Hello everyone, I'm Abhishek Chaudhary, your physics lecturer. Today I'm here to teach you one of the fundamental topic of physics, vectors. But before this we will start. Is it all set? Have you ever heard about vectors? Have you ever heard about this vector quantities and all? So you have, right? See, when you start this vector quantities, actual definition, example, this we will do obviously. Today's class will be completely for introduction purpose for this topic. But before this, I want to tell you, okay, it is not only one topic. You have to take this as fundamental of your physics for NEET syllabus. It's a very, very fundamental topic. Very, very, very fundamental. Means if you don't know vector, you will be struggling with many chapters in physics. So listen properly, ask questions, reply it, solve questions. Total engagement vector is asking you, right? Chalo, good morning. It has both magnitude and wow, yeah, nice. So we will start with this. First is physical quantity. Physical quantity that you study in physics and something that you measure, measured quantity. That you measure in physics, that is called physical quantity, and that is called measured quantities. You are measuring some quantity, you are measuring distance, you are measuring work, you are measuring velocity, you are measuring force. Many quantities you have measured. In this measured quantities in physics, you have two types of quantities. First one is scalar and the second one is vector. Scalar quantity and vector quantity. These are the two quantities you have to study. Okay? Scalar, vector. Here today we are to discuss vector, but why vector is needed, why we are discussing vector, for that you have to understand scalar also. So scalar quantities, they always have magnitude. When we say magnitude, what we represent, what we are up to, what we are trying to say, magnitude means what? Already we have discussed, no, that physical quantity will have the measured value. And you will measure, so some amount, some quantity, so you will measure, no. So that amount, that quantity that you are measuring in some numeric, that is called magnitude. So magnitude means numerical measurement. What you are measuring? Quantity. Unit, some unit will be there, numerical measurement. Measurement, that is called magnitude. For example, I will ask you what distance is your house from here. You will say some number. That number will tell magnitude, the amount. Vector, here it says I also have magnitude. What's the difference? Scalar has magnitude. Vector says I also have the magnitude. I have the magnitude also. We are same. Then vector says I have direction also. What we have? Direction also. I have direction also. Scalar says, now this is important. You have to listen this very properly. What scalar is saying? Scalar says may or may not have direction. May or may not have direction. This is the prime difference between these two, may or may not have direction. Generally we say, no, that scalar quantities will not have direction, but that's not completely true. There are many scalar quantities, those will have directions. Oh wow, yeah. Velocity is a vector, acceleration is a vector. My question is scalar quantity which is having direction. Many of you beautifully answered it, current. Good, clap for all. Current answer clapping is going on. All of you are clapping for current. Force is a vector, force is a vector, velocity is a vector. Manisha, right? Very good. So that answer is current that I asked you. What is current? Current is scalar. It is a scalar, but it has direction, and that direction all of you have studied, that is high potential to low potential. High potential, distance is a scalar. We will discuss all examples also. Distance is a scalar. Subhash, good attempt, but work is a scalar, beta. Okay, current, yes. So basically in this slide what we have got a scalar may or may not have direction, vector will always have direction, Second point, magnitude, both of them will have. Third, I am not going on. These two we have discussed. Now I am asking one more question. Venkat, speed is a scalar, beta. Speed is a scalar. It's not vector. Krishna, right? Right answer. Current is. Now one more question. Apart from physical quantity, I am asking. Are you ready to answer? Ready to answer? Ready to answer? First say me yes or no. I am going to ask one more. Apart from physical quantity. Ledu means so I know better. Ledu, no. You have to be ready to answer. Yes. Tell me one thing apart from physical quantity I am asking. What is hard work? You will do very hard work for your NEET, for your MBBS seat, for your dream college. What is hard work? What do you think? It is a scalar or vector? Hard work you will do, that is a scalar or that is a vector? Hard work. No, it's not. Yes, it's vector quantity, not physical quantity, but it is like vector. Hard work magnitude is important. You will do very hard work, 12 hours, 15 hours a day, but you have to have in a proper direction also. Directionless hard work will not give you a result. Hard work has to be vector for your NEET. Write in your physics vector notes, hard work, vector for NEET. Yes. Subramanyam, because direction, magnitude both are important. You cannot have may or may not have type of thing. No. Sometimes you will do hard work, sometimes you will not do. No, according to direction, not a physical quantity. Obviously, it will not obey Jaicharan. It's not a physical quantity. In our life, we have to take hard work as a directional quantity. Without direction, hard work will not pay the result. That I wanted to say, and many of you got it. Okay. Now see how you will represent a vector. Representation is this diagram. If you can see, that is the denotion here. I am writing here. Denotion you can say. Representation you can say. When I am representing a vector, please have a look to this OP. OP. O is called tail of the vector. What is OP? O is called tail of the vector. So here we are taking this as a tail. I'm changing the color if not visible properly. And this arrow is called head of the vector. Vector will always have a tail. That is just a denotion, how we denote it. Every quantity has some denotion. So this is a denotion. Whenever you draw a vector, I'm drawing like this. That will be the tail and that will be the head. Head is pointing the direction. And this total length of the arrow, that length of the arrow is called magnitude. Length of the arrow is called magnitude. As longer is the arrow, as higher is the magnitude. Shorter will have less one. Got this? Okay. Okay. Magnitude is this. Denotion, have you understand? Have all of you understood denotion? How you will denote it? One will be tail, one will be head. Head will be pointing the direction. If one more thing you have seen here, this is R vector. On R vector, we have put an arrow. This is called overhead arrow. Overhead arrow. Overhead arrow is also used to denote a particular vector. This is also denotion. This is denotion. That denotion is for any particular, like force I am representing, I will write F, overhead arrow. Velocity I will write like this. Acceleration I will write like this. Overhead arrow is just a denotion. It is not actually telling you the direction. Suppose I am saying force is downward. So overhead arrow will not be downward. Overhead arrow will be horizontal always. It's just telling that this quantity has direction. Particular direction if you want to draw, you have to draw separate arrow. That's the point. Understood this? First slide basic is okay. Overhead arrow is not actually denoting the real direction. Can we go to next slide? Yes. Now see, first one more thing in this, you must have seen in this slide we have written one thing, and that one thing is what? What is Q equal to NU? Q is the physical quantity, Q is the quantity, N is the number and U is the unit. So every physical quantity has a denotation. Quantity is equal to number into unit. Like I am writing force equal to 10 Newton. 10 is the number, Newton is the unit, force is the quantity. That is the denotation only. Okay. Physical quantity can be written. Yes, right. Dikshita, very nice answer. Now I am going to next slide. Again, we will discuss these definition in some more elaborated method. See this. Now read this slide. What we are going to do on this slide, properties that vector will have always. Little more elaboration. We have discussed these three, rather these two in the basic discussion. Now we will understand in elaborated method. As I told you, magnitude is what? Magnitude is numeric measurement. Numeric measurement. Right? You are measuring something, that is the magnitude. This is nothing to discuss about, that's a fact, that's a quantity. But direction has a very, very important discussion, how to denote. Vector will have direction, you know, all of you have answered also. Now my question to all of you, how to represent direction of a vector. Try to understand direction. If you, all of you, want to represent direction, you know now vector will have direction. Vector will have direction, then we have to denote it also, represent it also, numerically find it also. So that direction is what? It is, read it carefully. What is the direction? Direction of a vector is angle with a reference. Now we have to look into it because this is a numerical topic. We will do questions also. So please understand this very carefully. How to write direction of a vector. What you need to write at the first place, if you are representing a direction, you are calculating a direction mathematically, what you will write at the first place? You will write angle, 30 degree, 45 degree, whatever you want to, 90 degree. How to write, that is a separate discussion, but what we will write? Angle we will write. And that angle has to be written with a reference. Angle has to be written with a reference. How? Let's have a diagram here. In this diagram, this is beta G, y-axis. What is this? X-axis. And now I am taking one vector. Already I told you, arrow will be the head, this will be tail, and that is representation of a vector. But where it is directing, what is name of that direction? This direction, how I will say what direction is that? Vector is pointing somewhere, it has direction, but what precise name of that direction? So if I want to represent this direction, I will first make a reference. Reference, I am taking x-axis. If I am taking x-axis, I will measure angle with x-axis. I will say this alpha is angle with reference means x-axis, and that is representing a direction. If I am taking, suppose I am taking a reference as y-axis. So I will measure angle with y-axis. That angle I am saying beta, let's say. These alpha and these beta are representing direction for this vector. And this is with reference. So two things you have to represent to calculate direction. Just grasp this in your mind. You want to write direction, then you will not end up writing north, south, east, west. You have to write angle with a reference. Angle with a reference. Cos theta, yes, Vicky, that will be in resolution. First understand this. Are you getting how to calculate direction mathematically? What you have to write? You have to write angle with a reference. Now, if you have got it, I am asking one question here. Every question you can give yourself 4 marks. How many questions I will ask? You can give you 4 marks, and then end of the class, see what marks have you got. You can tell me in the chat box also what marks you are getting. So ready for this question? Next question. I'm asking question on that basis. I'm repeating. I have told you that vector direction is angle with a reference. You cannot write direction without the two things. You have to have reference, you have to have angle. Now my question to all of you. Ready? A vector can have how many directions? That's my question. This is +4 or -1, whatever you get, let me know in the chat box. My question is, a vector can have how many directions? A vector can have how many directions? Okay. So correct answer is infinite. It's not how many directions you can see. I'm asking how many directions a vector can have. Vector is giving you angle with a reference. No, infinite reference. Anything you can take reference. With every reference there is a direction, and with one reference also in space many directions are there. Here, there, every small angle I will change. Every differential angle. Angle is the direction, beta. And every small angle I will keep on changing. How many angle I will have? Vector can have infinite direction. Yes. If someone has not get it, I am saying, try to understand this. This is a reference line. What line? Reference line. And from reference line, I am drawing one vector. One vector I am drawing. This is the vector A. This angle, then 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 this angle. Every angle I am changing. All are separate directions. Every angle is the direction, Babu. Got this? And how many directions you can draw? Infinite directions you can draw. Have you got this? So if you got this concept, type thank you. Thank you, sir. You have to type one thank you means you have got this concept. I said, okay, don't type here if you don't want to. Okay. So this is one direction. This is one direction you have got. No, yes sir will not work. You have to, thank you should be there. 360 degree Rishita is a very genuine question. First of all, I appreciate you for a very good question. But 360 degree we have in a plane, Babu. In one plane 360. In space we have many angles. Only in one plane, no. This is one plane. Here will be 360 degree. But if you will come out of the plane, here, you will have many angle, beta. Chalo, theek hai. So we have got about direction, how to go with direction. What is direction? First I told you. Direction is angle with a reference. These two things must be in your mind, rather three. I'm repeating summary of this slide. I will go to next slide. After this, we'll ask you a question. So first summary of this slide is what is direction? Direction is angle with a reference. I don't have reference, I cannot measure. There should be a reference, there should be an angle. And how many directions a vector can have? Answer is infinite. That is one point. Now, this I will come in the separate discussion. I am coming on first direction. And one more question for direction. So be ready for one more question, one more concept clarity. And that question is in front of you this. Read the question once. Draw a vector 30 degree north of east. I will do it for you. I want you to get. But take a pen, take a paper, try drawing it. Thank you all of you. Okay. So this is the question. Please have a look. Numerical value, direction, okay. First read the question. Read this question. Draw a vector 30 degree. Read this. What is 30 degree? Everyone is aware from the lower classes that 30 degree is angle. What is 30 degree? Angle. And after angle, what we have written? After angle, we have written north of east. So this east, the last word, that will be reference. See, the question is giving you that hint. Direction means angle with a reference. You want 30 degree north. This you want 30 degree north. But from where? From east. Got this? So now reference, learn. Even if you know, just revise it. I will ask you one more question on it. This question I am doing for you. How to, step one, how to do the question. The step number one, my dear students, is always draw reference first. Always draw reference first. You have to start from the last. What is last? last is reference. The last word that you have to start solving question first. So my last word in this question is east. So I will start from last. That last word is reference. Draw reference first. So I have drawn east. That is the east direction. That you know, that is x-axis as well. That is the x-axis. East, x-axis can be drawn anywhere. But here I am taking x horizontal. But east on paper, on plane, we draw like this. That all of you are aware already. Now I will start from here. And where I will go? I will go east to north. Where you will go? East to north. So this is north, that is west, that is south. Where we have to go? We have to go east to north. How much I have to go? 30 degree. So this I will go from east to north 30 degree, and that is how the direction is drawn for a vector. 30 degree north of east. What is step 1? Draw reference. Step 2, what you will do, my dear students? You will go move from reference towards required direction, towards required. What is required in this question? North. What is reference in this question? East. So you have to move from reference to required. How much you have to move? That question is telling you to move 30 degree only. Got this? Understood this? Completed? How many of you match this answer? How many of you match this answer? Correct representation, correct answer. You have to write 4, 4, 4, 4, 4. Plus 4, plus 4, plus. I know now all of you will get plus 4 only. Good, yeah. Welcome, Vaibhav. Yes, 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 yes. Good. This is called rockstar crowd, no? All are getting plus 4. Yo, good. All of you. Now, should I ask you one more question? Okay, my rock stars. Okay, okay, okay. I know you are all intelligents. Okay. Now, one more question. Are you ready? Okay. Draw this. Question is here for you. Good. Now, draw 60 degree east of north. 60 degree east of north. That you need to draw. Giving you 10 seconds only to draw it on your paper. I will draw. You will match your answer. Okay. Do it, do it, do it. 60 degree east of north. Draw, everyone. Draw again. Jay Charan, your question, why we cannot take north as a reference? See, when I am telling Jay Charan, this explanation is for you. Listen very carefully. Suppose I am coming your home and I am asking you on phone, Jay, where is your house? You will tell me the direction of your house from some reference, from this building to left, from that building to right. So final destination is your house. So that I don't know where it is. So you cannot tell me the direction according to your house. So I want to go towards north. North is final. This is your house. You will tell me this direction from a reference, no beta. From somewhere you will tell me ki from east, sir, come 30 degree, you will come to my house. So always you have to start from the reference. Reference is always the known thing. Reference means what? That is known. In general, we saying give to reference. Mean to reference means that you know. So always you have to start from known and go to unknown. I hope you have understood. If you have to write thank you there. Or plus 4 also you can write. Chalo, chalo, chalo. Now I am drawing. Match your answers, everyone. 60 degree east of north. My step 1 is saying this, draw reference first. Reference is the last. What I told you, start from the last. What last I saw? North. That is the reference here. So I will draw north. That I will draw for last. I will draw first. That is the mandatory thing. After that, where I will go? I will go reference to required. So I have to move from, that is step 2 is saying, move from reference towards required. Reference to required is east, and how much I have to move? That also my question is telling 60 degree. Have you realized that these two are same direction? How many of you realize these two are the same direction? Because if this is 30, that has to 60, no. So this and that both are the same direction. If this is 30 degree, that is only we have changed the reference. Vector is there only. What we have changed? We have changed the reference. Earlier question reference was east. Now the reference is north. One certain direction can have many reference, that I told you in earlier discussion also. Like where earlier, let's have a look. Here I told you na, this vector angle we can measure with x, and this vector angle we can measure with y also. And you know that total angle is 90. So beta will be what? Beta will be 90 minus alpha. So if alpha is 30 degree, what will be beta? 60 degree. Same thing. So x is a different reference, y is the different reference, but vector direction is the same. The reference is Venkat right here. Very nice. You got the same? Say now, okay, nice. So this question you have to write +4 if you have got it right. Any of you have got +4, right answer, write +4. We should not take north on x-axis. It is nothing like that. We can take anywhere. There is not like it. There is a conventional direction for or drawing for any shape, but north can be taken in x-axis also. North can be anywhere. Chalo, I am telling you one thing that's for you. Everyone, please focus. A very genuine question you should know. What is north, south, east, west? Vector, you know, vector direction means angle. Now onward you will not tell ki sir vector direction is north, east. Vector can have infinite direction. And how to calculate mathematically angle. But my question, what is north, south, east, west? Whose directions are that? North is direction we know, south is direction I know. Whose direction is that? If I am saying it's not for vector always, whose direction is that? If that question you will know why I am not taking north on y or x. Anywhere I can take. Whose direction is north, south, east, west? That is the question number next. And in this question, again you will give marks to yourself. North, south, east, west. Whose direction is that? Direction is north, south, east, west. Whose direction is that? That you have to answer. Poles of earth. You are very, very close, Shoshan, but not right answer. Whose direction is that? Geographical direction. Where? Asini Srinivas. Right. Forward, backward. No. Geographical. Yes. Astronaut. Right. Surface direction. Beta, you are standing or sitting somewhere. I am standing somewhere. My surface, that earth surface, its direction here will be, my north can be in front of you. Your north, wherever you are sitting, can be in the right hand side of yours. So anywhere x-axis, y-axis, any axis can be north-south. It is not particularly direction of vector beta, it is direction of that surface is geographical. Yet I must say many of you have got very good mind. Right answer, at least every one of you is attempting. Good here. I genuinely appreciate for your attempt. Okay, keep rocking. Good. It is not always in the direction of vector. I'm coming Rajni for that. Now see, this we have discussed a discussion we have made on direction. What is direction and what is this? Now see, one more thing was there if you have read, and that is this, obeys laws of vector addition. So hold it for 10 seconds in your mind, revise direction and be ready to get the new concept. That concept is vector obeys laws of vector addition. I hope you will get it now. Should I start now? Okay, what this line means, you will read this everywhere. Every book, every module, everywhere that definition is written. But what is the meaning of this? Now to understand that meaning, no, not parallelogram, not triangle, this is separate. First you have to understand the concept of physics. The mathematics, the formula, they are secondary always. They are to help you in getting the numerical value. Physics is all about understanding the basics. That's why today's class is Introduction to Vector. Now I am going to elaborate this. I hope you will listen the way you are listening already. Obeys laws of vector addition. You know, vector has a complete different maths, its own mathematics. In mathematics, in the non-medical students, they have this branch of maths with them, vector algebra. Vector quantities have their own constitution of maths. They are not obeying the maths that normal arithmetic rules, whatever BODMAS, whatever you have done. Vectors are not interested in that. I will try to elaborate, explain this with some example. Suppose you are going to some other country. From India, you are going to UAE, or you are going to UK, US, you are going. That US or UK, the different country will have their own constitution, will have their own laws. Some laws that in India is different, in that country will be different. So you cannot question them why it is different. Their own constitution is that. Just for understanding it, not heavily related to it, but you have to understand in your mind, when I'm entering into vector, I'm entering into a separate country. It has its own constitution, own laws, own rules for mathematics. So your normal maths will say 2 plus 2 is 4. That is your normal maths. Your vector, if you are doing 2 plus 2, that might result to 3 also. So why 2 plus 2 is 3? Maybe 3. Or it may be, suppose sometimes it may be 0 also. So why this is so? So you have to understand that we say that generally we say that vector has a different maths, only obeys laws of vector addition. What vector is obeying? Vector is obeying laws of vector addition, but it is not only addition. What is this? Entire mathematics is different. Not only addition, what is different, my dear students? Entire mathematics, subtraction is also different. Multiplication is also different. There is no division, no multiplication, no normal. So what is this? Now I am explaining why vector addition is different. Please listen very carefully. Vector addition means resultant of vector. Resultant of vector. And what is resultant? Resultant means net effect. Resultant means net effect produced by vectors. Got it, Babu? Net effect produced by vectors. Now field is first before going on calculation. Okay, what is the question? Question is very simple. The statement first. What is vector addition? Vector addition is not interested in addition. Addition is a misleading term. Don't think addition here. That just for saying. Meaning you have to understand. What is meaning of vector addition? What is meaning of vector addition? Please read here, everyone. Vector addition is what? Resultant. What is meaning of resultant? Net effect. Net effect means what? Suppose this is any one of you. You can decide who is this. You can tell, I will write your name here. You are starting from here and you have reached to a point A. You have reached to the point A and you spend some time there, and then you have reached to another point, and that another point is B. You have started from O. And then you have reached where? You have reached to a point A and then you have reached to point B. Understood? Now tell me what is the net effect? Net effect. Net effect, who will tell? Hi, tell hi to me also. You are saying hi in yourself. Hi. I also want your hi. And this question also want your hi. Okay, what is the net effect here? Net effect. OB, not BO. OB. You have started from O and you have to reach at B, final point, initial point. That is called net effect. You have gone from here to A and then you went A to B. But where you actually net effect, please think in the question. Net effect is O to B, and that is called vector OA plus vector AB, and that is called the net effect, and this is called the vector resultant. So vector addition means this. But from the property of triangle, all of you are aware that sum of two sides are always greater than the third side. Suppose I am saying this is some side X, this is Y. If I will add the magnitude, no, if I will add the numerical value, I will not get the same. This is not equal to x plus y. But the point is, in vector addition, we don't add numbers, beta. We don't add numbers. We only see what is the net effect. But go to A also. Why not OA? Verb, initial to final. Vector addition, initial to final, initial to final, initial to final. That you have to think. From where you started, Babu? O. Where you reached? B. So vector addition is a net effect. What is the net effect? From where we started, from where we reached. So that is from O to B. That is called the net effect. Understood this? Initial to final. Good. If I am asking you in this question, one more question I am asking, see. This is a vector A, right? And here is the vector B. And then I am writing this as vector C. Which vector is addition of whose two? That is your question. Which vector is addition of what two? Chalo, chalo, chalo. All my dear students, come to this. Which vector is addition of what two? 10 seconds you have. A plus B equal to C. B plus C equal to A. What is addition of what? So see, you have started from point O. Always start initial to final. What is giving? That very simple thing you have to start. Very good here. You have started from which point? You are starting from O and you are going from O to A. Which vector is helping you to go from O to A? Vector A. Then you are going, see, you are going from A to B. Which vector is helping you to reach from A to B? B. O to A to B. What is the final effect? Final effect is O to B. Final effect is O to B. So that is vector C. And that vector C is initial to final. Initial to final is always vector resultant, vector addition. That is addition of two vector A and B. We have just started it. Tomorrow we will have an elaborated discussion on vector addition. Just today only thing you have to know this much. Only this. Initial to final is the net effect. Nothing else. Just grasp in your mind what is vector addition. Initial to final. Initial to final net effect. More elaborated discussion is in tomorrow's class. All of you got this. Total marks got 15. 1 minus you got. Okay. Chalo. But this is a very good effort. 15 little star is very good marks. Now I will take your 1 minute here. Just 1 minute. See this. This slide is all for you. Please have a look in 1 minute everyone. 10, 10, 10, 15, 16. Clap for 16 one. Just see this point. All the directional quantities are not vector. Points to be noted, my dear students. All the directional quantities are not vectors, but all vectors will have direction. Do you agree or not? Tell me this. From this, do you agree or not? All of you? 16. All directional quantities are not vector, and we discussed this initially. Current is having direction from high potential to low potential, but it is a scalar quantity. So that is one point. Note it. All we have discussed already. In just summary point, I have written it for you. Next, a vector changes when rotated. This also we have discussed today. Till when? This is a vector and this vector has an angle of theta. When I am rotating this vector, I am changing its angle. And when angle changes, vector direction changes. So that is the written. Yes, change in. Very good here. Too good. Vector changes when rotated, but remains same if shifted parallel to itself. This is one vector A, and I am just shifting this vector here to here. Tell me one thing, have I changed the direction? Have I changed the angle in these two? Just parallel shifting we have done. Have we changed the angle in these two or not? If we have not changed the angle, it means direction has not changed. Magnitude already same vector A. Neither magnitude changed nor direction changed. It means vector is same. Okay, got this? Clear? All of you have understood the very basics of vector today. We will meet tomorrow for vector addition basics. Today we have started basics of vector addition. Tomorrow we are going to discuss in elaborated manner what exactly is vector addition. Tensor is not in syllabus question for, I will tell you briefly. Tomorrow I will tell you, try to tell, but it's not for your NEET syllabus. Okay ji, chalo bye bye. God bless. Enjoy. See you tomorrow. Bye 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 bye.
This is Amit Bhardwaj, and I will teach you chemistry, some topics today, right? And we will discuss today the topic concentration terms. I hope everyone is good and it is audible to you and visible as well, right? Good morning everyone. So up to now you have done mole concept, right? Little bit about mole you have done. So this topic will relate that how mole can be used further, right? The topic concentration terms will come in 2 chapters, right? As the topic I am saying, like you will study first chapter stoichiometry. In that you will see it is a topic, and again in 12th chemistry you will see a chapter solution. Again same topic will come, and you will see it will be used in almost 7 to 8 chapters. Right? It will be used in 7 to 8 chapters. That means many questions depend on this topic. Right? Clear, bache? So let us start with our topic concentration terms. Right? So you will see it will connect you to your daily life also. There are so many examples I will show you that how we can use this term in our daily life question. Right? So we will see. First of all, let us understand what is solution, because concentration term topic will come in solution, right? Okay, Basha, let us start. So first of all, just tell me what is solution, right? First of all, tell me beta, what is solution? Everyone know about this, right? A solution is a homogeneous mixture of 2 or more substances, right? In our daily life, we are dealing with so many solutions, right? A homogeneous mixture of 2 or more substances, right? We can see the simplest example here, right? The simplest example is we have our water, and in that we are having salt. Fine. So salt solution is our homogeneous solution, right? So we'll see, I'm writing here salt plus water. Salt plus water, if you mix, it will form a homogeneous solution, right? Yes, everyone? Yes, you are giving right answers. NaCl solution. Yes, a mixture of 2 or more substances, and definitely it should be a homogeneous mixture, not heterogeneous, right? So first of all, let us understand what is the meaning of homogeneous, right? Because a mixture can be of 2 types. A mixture can be a homogeneous mixture or a heterogeneous mixture. So, but only homogeneous mixture we can call as what? Solutions, right? So if you see, homogeneous mixture means what? It should have uniform composition, means 2 substances which you are mixing should be mixed very properly. Yes? Right, very good. So you see, if you see everywhere the amount of salt is same. Everywhere amount of salt in water is same. If you taste this solution from here or taste solution from here or taste from anywhere, the taste will come out to be what? Same. I am saying once again, what is the meaning of homogeneous mixture? It means the 2 components should be mixed very properly. means uniform composition. If you taste this salt plus water solution, you will see the taste will remain same everywhere. Clear? Whereas if I say, if I am having a sand plus water solution, assume I am having a sand plus water. We are having a sand plus water mixture, right? So you will see more sand will be here, downside. Right? So if you mix sand and water, tell me, it will make a homogeneous mixture or heterogeneous mixture? Tell me, bache. Yes, everyone? It will make a homogeneous mixture or heterogeneous? Definitely, you will see more sand is here, not upside. So it is not a uniform composition. It is not a uniform composition. That's why you will say, we call it as heterogeneous mixture. It is a heterogeneous mixture, right? Yes, very good, very good. All of you are doing great. All of you are doing great, beta. Very good. Now our question is, can I call this mixture as solution? Can we call this mixture as solution? Tell me yes or no. Can we call this mixture as solution? Yes, everyone? Can I call this solution? Sorry, can I call this solution? Tell me. No. Very good. Not a solution. It is not a solution. It is not a solution, right? You will see in your further classes, actually I will call it suspension. It is not a solution, it is a suspension. Okay, we have a very good answer. Yes, because composition is not uniform. Here one thing is more, here sand is more, here sand is less. So it is not a solution. We call this suspension. Very good, very good. Great. Okay, great. Okay, bacha. So our topic, concentration terms, will connect us to the solution. We will use this concentration term topic in our solution topic, right? Okay, bache. Now we are clear. Now, one more thing. What is the meaning of a binary solution, right? What is the meaning of a binary solution? A solution of two components. A solution of two components is known as binary solution, right? It is made up of only two substances. It is made up of only two substances, right? So a solution of two components we call binary. What is the meaning of binary? Binary means two. A solution made up of two substances. Very right. Very right. Great. Here. So I will say the one component is solute and the other component beta is what? Solvent. Solute and solvent will make our solution if you mix them properly. Solute, solvent will make our solution. Very good. Great, great, great. Yes, beta. Now tell me one more thing. Solute is which component? Which is present in large amount or in less amount? Yes, everyone? Solute will be present in large amount or less amount. Out of two components, solute and solvent, solute is the component which is present in less amount. Very great. Good, good. And solvent will be in large amount. Very simple thing. So here if we see, solute will be present in less amount and solvent will be present in large amount or more amount. Clear? Right? So out of this, if I say in our salt plus water solution, what is salt? Salt is solute. Very good. And what is water? Water is solvent. Very good. Great, great. Solute plus solvent will make solution. Solute is the component which is present in less amount, and solvent is the component present in large amount. For example, in salt plus water solution, salt is less only, water is more, right? So water is solvent. And what is salt, beta? And salt is what? Solute. Great. Yes. This is the definition of solution. Now we will enter in our topic concentration term. I am saying once again, a homogeneous mixture of two or more substances is known as solution. Homogeneous, be clear. Next point, a binary solution is a solution made up of two components only, not more, made up of two substances. Okay, means only one solute and solvent. Clear, everyone? Yes, I hope everyone is good about this topic. Now we are going to start our topic concentration term, right? Clear, Cha? Right, right. Great, great, great. You will see in our topic concentration term, we will deal with many concentration terms, right? Out of these, we will try to cover three today. The easiest one, right? So the first term we will use is our weight by weight percentage. The first topic is weight by weight percentage, right? So what that means? And one more thing I will say. When I will teach all these terms, topic by topic, I will ask you one question, that which one of these is temperature dependent and which one of these is temperature independent, right? So you have to learn just one thing. If in any term, if in any topic I am using volume, if in any topic I will use volume, that will be temperature, what? Temperature dependent. If in the term, in the formula we are not using volume, yes, if in the formula we are not using volume, that means it will be temperature independent. Getting my point? I am saying once again, those concentration terms in which volume will come somewhere, so these will be temperature dependent. And whereas if volume is not coming anywhere, only weight is coming, something like that, so those are temperature independent, right? Clear, Bachcha? Right? So our first term is weight by weight percentage. Yes, beta, try to understand this. What is the meaning of weight by weight percentage, right? Yes, very good. And one more thing I will say, Bachcha, if you will understand this topic, you will be more close to a NEET selection, right? Very good. So instead of doing other chats, try to focus on the questions I am giving here, right? So please. So first of all, we are dealing with weight by weight percentage, right, Bachcha? What is it? It is the weight of solute. Very, very easy topic. How we can find weight by weight percentage? So it is weight of solute divided by what? Weight of solution. Weight of solute divided by weight of solution into 100. This is the weight by weight percentage. Very easy. I'm saying it will show us what? How much solute is present in how much weight of solvent. That is our weight by weight percentage. I'm saying once again, weight of solute divided by weight of solvent will give us weight by weight percentage of our solution, right? For example, I am giving Bachcha here For example, here we have an example. I'm saying this have NaCl. We have here NaCl. How much NaCl we are having? Assume I'm saying 20 gram NaCl is present here in how much solution? I'm saying here 200 gram solution. We have 20 gram NaCl in 200 gram solution, right? Can you tell me what is the weight by weight percentage of this solution? 20 gram NaCl solute is present in total 200 gram of solution. Tell me the percentage weight by weight. Yes, everyone, good, very right, very right. Most of you are giving right answer. Very good, very good. So very easy बच्चे, 20 gram solute, 20 gram solute in how much solution? 200. 20 gram solute in how much solution? 200 into how much बच्चा? 100. That's it. If you try to solve this, what will come? This will cut down. This will cut down. How much will come? 10%. How much will come? 10%. Very good. See how easy it is. Very, very easy, right? It's very, very easy. Now, one more example I am giving. Give answer very carefully, right? Next example is, here we have sugar. I am saying here, we have sugar, bacha. We are having 30 gram sugar in 120 gram water. So find the weight by weight percentage of solution. I am saying once again, 30 gram sugar in 120 gram water. Give the answer very carefully. Some are doing right, some are making mistake. Most of you are doing mistake. Check carefully, check carefully. Very good. Check answer very carefully. Right. Half of you are giving right answer, half are giving wrong answer. Karthik gave the right answer. Very good, very good. Very good. Listen to me carefully now. Listen to me what mistake you are doing, right? What we are doing here, we are having 30 gram of solute. We are having 30 gram solute. But one more thing, it is weight of solution or weight of solvent. It is weight of solution or weight of solvent. It is weight of solution. So beta carefully, it is solute, it is what? Solvent. So what is total weight of a solution? 30 plus how much? 120. 30 plus 120, very good. Into 100. So from here, you will see 30 divided by how much coming? 150. Then 100, right? So from here it is coming 1, here how much? 5. 5 will cut down 20. Very good. Now you are giving the right answer. You understand the mistake? What mistake you did? You just took the weight of solvent. Be clear here. We have to take weight of solution, not only solvent. Very good. Okay, fine. It is not 25, it is 20. It is not 25, it is how much? 20. You will not take here 120, you take how much? 150 weight of solute plus solvent. That means weight of solution. You will take weight of solution. I hope you are clear. Very good, very good. Very good. Okay, now I will move to next one. Right? Next question, bacha. Very good. Okay. I am giving next question. Same question I am giving. Carefully give me answer this time. Same question I am giving this time again. Imagine here we have 10 gram glucose. Here we have 10 gram glucose, and here we have it a 140 gram water. This time don't make the same mistake. Find the weight by weight percentage. Don't make mistake this time. Same question I am giving. 10 gram glucose in 140 gram water, right? Right. Very good. Right answer is coming. Right. Very good. Right. So see how easy this topic is, right? Very easy. So I will say 10 gram glucose means solute. Divide by how much? Solution 140 plus 10 into 100, right? So what is coming from here? 10 divided by 150 into how much? 100, right? What will happen from here? If I cancel out, what is coming? 2 here, 3 here. It is giving 20 by 3, right? Yes. What is coming? 6.666%. Very good. I hope you understood your mistake, right? Now, a reverse question, right? Find weight of glucose present. Find weight of glucose present in 300 gram solution. In 300 gram solution, which is 20% weight by weight glucose solution. Right? This time weight by weight is given. They are asking what? Weight of solute. They are asking weight of solute. Very good. Some already gave the answer. They are asking weight of solute. What is given? Weight of solution. And what is the weight percentage beta? 20%. Very good. 60. Very good. Everyone doing great. Everyone is doing great. Very good. Right. Very good. So we can see, bacha, we see here the solution part. The weight percentage is 20. We want to find the weight of solute, weight of glucose. Divided by weight of solution. How much solution? 300 into 100. Very good. We will just keep things in the formula. We want to find this. We have solution weight, we have weight percentage. This so we know already. Yes, how much coming? Weight of solute 60. Very good. Very good. Great. Very good. Now, I hope everyone is doing great here. The next point you have to understand how we will use moles here. You have done topic mole. It's bacha. So I will use mole now in this topic. It's in our weight by weight percentage. We will use mole, right? Just for your information, just for little revision only, I am telling here. What is mole here, right? So mole was, number of mole is given weight divided by molar weight, right? Remember that? Number of mole is given weight by molar weight. Clear, bacha? Now, if you want to find weight, so what is weight? Weight is number of mole into molar mass. So please remember this formula only. You know this already. You have done many questions, right? I will use this now in our question, right? If you want to find the weight of something and you have its moles, so please multiply the number of moles into its molar mass. Clear? Now we will use this in our questions. Fine? Very good. Great, great. Yes, everyone? Okay, so please, I am taking this question here. Now, I am giving question. Again, this is our solution. In this you will see, I am saying we are having 1 mole of NaOH. Here we are having 1 mole of NaOH, right? I am saying mole. So we have to find weight, right, according to this. And here I am saying, imagine bache, if I say 10, I am saying here what is present? 10 mole of water. We have 1 mole NaOH and we have 10 moles of water in our solution, right? So what we have to find? We have to find weight by weight percentage. Again, right? So first of all, convert mole into weight. Here also mole into weight. Then try to find the weight by weight percentage. Very good. Yes, everyone? Yes. Just you have to use the same thing. What you will use? You have to find weight. How we can find weight? Number of mole into molar mass. Number of moles into molar mass, right? How we can do that, beta? See here. I want to find weight of NaOH. How I can find that? 1 mole into the molar mass of NaOH, how much? 40. Yes. 1 mole NaOH means 1 mole into 40 is the molar mass. So how much will come? Yes, it will come 40 gram. Yes, it will come 40 gram. Next thing is, I have 10 moles of water. I have 10 moles of water. What we can do here? I want to find weight of water also. How? Number of mole into molar mass. 10 moles. The molar mass of water is how much? 18. Okay. So it is coming how much? 180 gram. It is coming 180 gram. Very good. Very good. Right? Clear, bacha? So you will see weight of NaOH. We have to take weight of NaOH because it is our solute divided by weight of solution into what? 100. So look, bacha, what do we have here? Weight of NaOH here 40. Weight of solution 40 divided by how plus how much? 180 into 100. Very fine. What is coming from here? 40 divided by 220 into 100. Clear, bacha? Yes. So what is coming from here? If we cut down this, we cut down this from here. If you cut it down further, it is coming how much? 5, 11. So it is coming how much? 200 divided by how much? 11. Right? Clear, bacha? Very good. 200 by 11%. 18.18, right? 18 point something will come. Very good. 18.18. 18.18. Very good. Very right. Very right. 18.18. Bacha, if you solve this, 18.18. Very right answer. I am giving same question. Please answer this again. Same type of question I am giving here. Answer it carefully. And I will give you a hint also. Don't worry. I will give you a hint also, right? So, I am giving here that we are having 1 mole glucose. We are having 1 mole glucose, and I am giving that in this we have 1 mole glucose. First thing. And total weight of solution how much? I'm saying imagine we have 360 gram of total solution. So again find what? Weight by weight percentage of solution. Yes everyone. And what is hint here? What is hint here? The molar mass. I'm giving here the molar mass of glucose is how much? The molar mass of glucose is how much? 180 gram. Molar mass I gave you already, right? Molar mass is given to you. Molar mass is given to you. Very right, very right. Yes. Yes, beta, Shakir will talk about it. How to find molar mass. I am giving you molar mass. Don't worry about it. Very good, very good. First of all, I want to find the weight of glucose again, right? How I can find the weight of glucose? Weight of glucose is how much? Number of mole into molar mass. For now, I will give you molar mass, right? Don't worry about it. But I will tell you how to find it, but still you will learn step by step. How many moles? 1 mole. 1 mole into what is molar mass? 180. How much comes? 180 gram, right? Now if you see, we want to find the weight by weight percentage, right, Richa? So 180 gram solute divided by what is weight of solution? 360. Weight of solution how much? 360. So what is coming from here? Yes, very right answer. Most of you give the right answer, 50%. Yes, 50%. It is coming how much? 50%. Very right. Great. Great, great. I hope you understand now about this topic. I'm saying once again, how to find the molar mass you will see step by step, right? It depends on the elements, which element it is having, right? For that, you should know the formula of glucose also, C6H12O6. So you will learn these things step by step, but for you, it is important now. Okay, we will teach you everything step by step. Okay, don't worry about it. Okay, Ucha. Right, right, very good, very good. Now, next one we are coming. Our next concentration term is weight by volume percentage. Again, a very simple term like the previous one. Again, right? It is what? Weight by volume percentage. Very much, very, very easy beta. Again, same thing. It is what? Weight of solute. Weight of solute divided by volume of a solution. Right? But be careful, you have to take the weight in grams and volume in ml. Weight of solute in grams divided by volume of solution in ml, right, Bacha? Into 100. Into 100, right? Into 100. So weight of solute in grams divided by volume of solution in ml into what? 100. Right, very good, very good. Right, very good. Now, first of all, let me ask you one question. This term, this weight by volume term, in its formula, volume is coming somewhere, right? Yes or no? In this, somewhere volume is coming, yes or no? Volume of solution, volume is coming, yes. So that's why this term is temperature dependent. Yes, that's why this term is temperature dependent. This term is temperature dependent. Whereas the previous one, weight by weight, in that there was no volume term, right? That was temperature independent. The previous one, weight by weight, in that there was no volume term, so it was temperature independent. It means If you change temperature, the value will remain same. But in this case, if you change temperature, volume, in this case, if you change temperature, the value of this concentration term will change, right? Okay, we'll understand these things. First of all, weight of solute divided by volume of solution. Very good. Please answer this easy question. Very, very easy again. I'm saying here, we are having 40 gram, or I'm saying, okay, 20 gram. 20 gram urea is present here in how much solution? 20 gram urea in 200 ml solution. In 200 ml solution, right? So please find the weight by volume percentage. Yes, bacha. Find the weight by volume percentage. Very good. Very easy term. Very good, very good. Everyone is doing great. 10, 10, 10. Yes, great, great, beta. Very good. We will see how much weight of urea, 20 gram. How much is the weight of solution? Sorry, volume of solution, 200 ml. Into how much? 100. Yes, what is coming? 10%. Very good. 10%. Very good, very good. Right? Very good. Now I am giving a little tricky question. Little tricky question, so be careful and give the answer right. This is we have here. Again, almost same question I am giving. Assume we have 20 gram urea. We have 20 gram urea, and I am saying here we have 200 gram solution, right? And you will see, given that density of solution, you know what is density, beta? Density of solution is given as 1.2 gram per ml. They have given density time. They have given density, right? Now we have to find again weight by volume percentage. We have to find again weight by volume percentage, right? Hint I am giving to you. I am giving hint here. Hint is weight of something is volume into what? Density. So volume is what? Weight by density. Yes, use it. It's better use it. Volume is weight by density, right? So from the weight, first of all you have to find the volume. Then you have to go. Very good. Right, right. You're doing great. Very good. Right, 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 right. Okay, fine. Very good. So what do we have, bacha? See carefully. First of all, we need volume. Volume of solution, how you can find weight of solution divided by density of solution, right? What is the weight of solution? 200 gram. What is density given? 1.2. So it is our volume, right? 200 divided by 1.2 is our volume, right? So from here, now it's very easy to find the weight by volume percentage. Find, bacha. How you can find that? You will see weight how much? 20 gram urea. What is volume? 200 divided by 1.2 into how much? 100. Very right. Right? Very good. So what is coming from here? If I write properly, 20 divided by 200, 1.2 will come upside into how much? 100. Now if you cut down, what is coming from here? 10. 10 will cancel this 1 0. Very good. What is coming? 12%. It is coming 12%. Great. Great, great. Very right, very right. Right. Good, bache, good. Done? Okay, I will take 1 more minute just to give a relationship between what? Weight by weight percentage and weight by volume percentage. So that you can directly convert your weight by weight into weight by volume or weight by volume into weight by weight. Very right answer. Look carefully. We know that weight by volume percent, right? I can write it as weight. Volume is what? Volume is, I am writing it very clearly. It is weight of solute divided by volume of solution. So I can say weight of solution divided by density of solution into 100, right? So if we just solve a little bit, what is coming? Weight of solute divided by weight of solution into 100, and density is coming here, density of a solution. Very good. We know this value, what we call this? It's our weight by weight percentage, right? So I can write here weight by volume percentage is what? It is weight by weight percentage into what? Density of solution. So we have a relation. Yes, we have a relation between these two terms, right? If you want to convert one term into another, so just you can use the relationship and get direct transition. Clear, bacha? Right? So today we covered only 2 topics, right? Which one? Weight by weight percentage and weight by volume percentage, right? So I hope it will help you. Tomorrow we will see the next type of concentration terms, right? So please use these notes. We will send this on your Telegram. So if any point you are missing, please look into notes, and if something is missing, so you can ask tomorrow as well, right, bacha? I hope this will benefit you. Okay, okay, bacha. Bye. See you tomorrow. Bye, everyone. Bye, everyone. Bye.
Today in our botany session, where we have already started with the chapter morphology of flowering plants. Till now we have discussed the vegetative morphology, and already we have started with the reproductive morphology in the flowering plants. I hope so you have gone through the revisions of the thing, and we have to go with the little bit recapitulations of the points once again. In the case of reproductive morphology, we have discussed the reproductive unit in flowering plants, a flower. Its structure we have discussed in the flower. We said that it is the unit of reproduction in the flowering plants, and we said that they are having the 2 parts, essential and the non-essential, that categories of the parts are there, right? Now a question for you people. We discussed under the essential parts of the flower, stamens and the pistils, right? You have to say me that polyandrous condition we take in the case of androecium or the gynoecium, polyandrous condition, androecium, right? And in which case, or you can say the term what we used when the carpels are free. When the carpels are free, you call it technically, scientifically is what? Apocarpus. Very nice, right? So you must know apocarpus condition is for the free carpels, right? And in which case, okay, I give you the statement, you have to give me one term again. I am giving you one more statement. When you are having many bundles united of the stamens, stamens when get united in many bundles, it is not only a Delphi, this is polyadelphous, very right. So Even students are giving me the response and maximum of you have joined that. So let me to start with us today's class. In our today class, to start with a new topic, let me to talk to you regarding two more headings, or I must say subheadings under the flower. What are that? First of all, we will discuss again regarding the types of flowers. Earlier we discussed the types of flower based on whether the number of whorls are all four are present or not, means complete, incomplete flower. Then we have discussed the types of flowers based on sexuality, unisexual and the bisexual flowers. Then even we discussed the types of flowers based on symmetry, actinomorphic, zygomorphic, asymmetric flowers, right? Then we have even discussed the types of flowers based on the merosity, trimerous, tetramerous, pentamerous flowers we discussed. Now today one more category of flowers. Let me to wind it up with the flowers and inflorescence part in our today's first half of the session. Then we are going to take in the next half of our session about the fruit, right? So I repeat once again, we are going to take in the beginning a small topic regarding types of flower. One more category we are pending with. So let's have a look on that. We are having these types of flowers based on the position of the floral parts on the thalamus, right? Thalamus, I hope so you remember. If I take this introduction here, I already mentioned you, this is a thalamus and the stalk of the flower, what we call it as pedicel, right? And this condensed part, what we call it as a thalamus, right? So on that thalamus, we have discussed all the reproductive parts, or you can say essential, non-essential, both are present. Now on this thalamus, how the arrangement of the parts happen? Either of, I mean say collectively we are here talking about the non-essential and essential parts of the flower, right? Like let me to take here, outside which part is there? Sepals. Then inner to that, what is there? Petals. Right, then still inner to that, what will be there? Stamens, right? And innermost we are having for the pistil or the carpel, right? So that points we have discussed, right? Now let's check about the position, how they are arranged. Even on their, based on their positions, we are having different types of the flower. Like first, can you see? Just focus on the first diagram. Don't look all the diagrams at once. In the first diagram, this green part is the thalamus. This is the pedicel part. This is the female part. In this type of flower, female is at the topmost position, whereas the rest of the parts, can you see, they are below to that, right? Rest of the parts you will find it will be below to that, like this. Can you see this one? This will be below to that, right? Being they are below to the gynoecium, such type of flower you call it as hypogynous flower, right? So here gynoecium is at highest position on the thalamus. On the thalamus, what this part is indicating? This is indicating the thalamus part. Fine. On the thalamus, the female part is at the topmost, rest other part is down. As other parts are down, that's why you call it as hypogynous flower. Hypo means what thing? Below. Hypo means what? Below. Gynous means gynoecium part. Fine. And what can be the example over there? Here the example will be of China rose, again very important. Even the example will be of mustard. Then even the example will be of the tura, right? So you will find all these examples from the NCERT book. I am not taking any of the new examples here. All are from your NCERT book, right? Now next I am taking for one more category of flower. To understand this one, just have a look on this diagram first, right? This diagram. In this part, can you see this thalamus has make a cup shaped structure, right? The thalamus has formed the cup shaped structure, and if this is a cup, can I say this is a rim of the cup? which word I have used here? This is the rim of the thalamus. This is the rim of the thalamus. Like a glass is there, no? This is the rim of that, the top surface that you call it as a rim. On the rim, what are there? Other parts of the flower. Whereas the thalamus, this is the thalamus, which has make a cup-shaped structure. On that structure, what is present? Other parts. Whereas the gynoecium will try to, or you can say other parts, try to reach at it same level. Right? I repeat once again, when the parts other than gynoecium, they are present on the rim of this cup-shaped thalamus. Right? And gynoecium is going to be almost equal in height with respect to other parts. Such condition, you call it as perigynous condition. Looking to the picture, you should be clear to the things. I again repeat this point. When thalamus is making a cup and on the rim other parts are there, and these parts try to reach at the same height of gynoecium, that you call it as perigynous. And here can you see the ovary? From here it will be half outside and half inside, right? And that you call it as half inferior ovary, right? Inferior means downside, superior means outside. In this case, you will find it is completely outside. Here you will find it will be completely upper side. There is no cup shape formation. That's why here you can say ovary is superior. What is superior here? Ovary, right? Ovary is superior in this case. Fine. Whereas here the ovary is half inferior, or you can say half superior. This is which condition? Perigynous condition. Are you getting that? Now, what is the example over there? Here the example will be plum, peach, or even the rose. These can be the example. But even this condition is coming under perigynous condition. But you will find a slight problem in understanding this diagram and this diagram. Let's talk about this diagram first, then I will come back on this LS of the flower. LS means longitudinal section, right? We are cutting the flower in the longitudinal section. So I will come here after discussion of this. Now what is present, what type of gynoecium and how they are going to be arranged here. When you have a look, again this is the thalamus part, but can you see the margin of thalamus? The margin of thalamus that grows and covers the ovary completely. When they are completely covering the ovary, and or you can say touches to the wall of ovary, right? Such type of condition, you call it as epigynous condition. Why epigynous condition? Because here the other members will reach above the level of the female part. Can you see they have reached above the level of the female now? That's why the word is epi. What do you mean by epi here? Epi means it will be above. Right? From the diagram you will find gynoecium is here, other parts is above that. That's why it is epigynous. In this case, they are going to be like in hypo condition based on this thalamus position, based on that, right? And here even it will be risen up, or you can see from here even. The complete ovary is downside. That is the epigynous condition. Other parts will come above. Here the female part ovary will be half upside and half down and almost reaching at the same height from the top. And in that case, can I say the ovary is going to be inferior? Ovary is inferior. Inferior means it will be down, embedded in the thalamus part. But if I compare this diagram, last one, with this, can you see here the wall over there, but it will not join with the wall of that. Again, that is perigynous condition. Both the diagrams are of perigynous condition, but difference between the second and the last one, here the thalamus wall or the margin is fused with the ovary wall, but here there is no fusion. That's why this comes under the perigynous condition. Right, so in your NCERT book you will find these two conditions under perigynous, last one you will find in epigynous, and first you will find it in a hypogynous condition. Now example for the epigynous condition, for this part what can be the example? Here can be the guava, can be the cucumber, and even the ray florets of sunflower. Ray floret of sunflower, right? So these three just terms meanwhile you should know. Let's recapitulate this point once again. Hypogynous, hypo means something is below to the female part, means other part, androecium, petal, sepal, they are below than the this part of gynoecium, and female is at the topmost position, the other are below, that's why hypogynous. Female or ovary is superior in this case, that's why we have written ovary superior. Here what happens, the thalamus make a cup shape structure, on the rim of that other parts are there and they try to reach at the same level of gynoecium. Such condition you call it as perigynous. In other case, again cup is formed, but it is so much depth and going to be overgrow and fused with the wall of ovary. And in that case, completely ovary is embedded by the thalamus. Ovary is inferior here. What can I write here? Ovary is inferior here, right? And such condition you call it as epigynous condition, right? So here we are going to take the concept of the flower reason, because we have to touch to our today's topic, the fruit, right? But this topic I thought it is important I should say to you, that can help you to start with your +1 syllabus, right? Just once you are familiar with the words, I think so when you are listening in the class again, when you will come, it will make you more helpful and going to retain, and like a revision for you, which help to retain for these terms for longer time, right? So it is important topic, that's why we have covered here. So this is about the types of flowers based on the position of floral parts on the thalamus, right? Now let's take one more topic here, that is about the inflorescence. Now what is inflorescence? Even it comes under reproductive morphology of the flowering plants. This is the arrangement of flowers on the floral axis, that you call it as the inflorescence. Now what is this floral axis? When you see some flowers, a bunch of flowers is hanging or there on the plant, this complete where flowers are there, that you call it as floral axis. I will show you through one diagram, but right now just listen to the concept, then through the diagrams and the pictures I am going to explain you. And inflorescence, if I go with its types, right, it consists of main two types, or majority two types are there. What is that? What are the two types? That will include first like racemose type, next is the cymose type, right? So this is the name of the major two types of inflorescence. Now racemose is what? When the floral axis, this is the floral axis, it keep on growing, and suppose this is the stem by which it is attached. The floral axis, this is a floral axis where flowers are going to born, that keep on growing, right? And the older one flowers are at the base and younger one are at the tip. And I said you they are having bracts on their flowers, right? So this arrangement or this type of inflorescence you call it as racemose, where what I said, the floral axis, right, the floral axis shows unlimited growth, means they keep on growing, right, and are showing acropetal arrangement of flower. I hope so you remember the word acropetal. We have discussed in the leaves even the acropetal arrangement when the younger are at the top or at the apex. Apex, what it is having? Younger things. And at the base, what is there? We are having older things. But here we are discussing about flower. When such type of arrangement is there, you call it as racemose. Cymose is what? The floral axis that will ends up into the flower. Now what type of arrangement they are having? Basipetal arrangement. Basipetal arrangement. Now how this arrangement is there? Let's check on this diagram for this. When you will have such type of thing here, you will find the arrangement. This is a floral axis. Please have a focus here. The flower first will form here. Means, can I say this is a first form flower? So it is going to be the older flower which is going to be at the apex, at the tip. And younger one now are at the base. These are their bracts, right? So this you call it as basipetal arrangement. In racemose, what is there? Acropetal arrangement. Here the floral axis will keep on growing. Unlimited growth is there. Here can I say the floral axis, this is having limited growth, right? And looking to this thing, don't say that the flower or inflorescence, I must say here, inflorescence keep on growing. It is not like that. There is certain season, there is certain month for the flowering to happen. After that, fertilization will happen and ultimately we will get the fruits. So throughout the life, they are not there and keep on growing. But whatever time they are there, they keep on growing with their floral axis. So acropetal arrangement is in racemose, whereas basipetal arrangement is in cymose. This point is very, very important. If you are understanding the word acropetal, basipetal, many times in the NCERT book, these terms have been used. Like just now within this short duration, we have used 2 times the word acropetal. One in the leaf arrangement, second in the racemose type of inflorescence. We have discussed this point, right? So I again repeat, in acropetal arrangement, younger at the top and older are at the base. In the basipetal arrangement, older are at apex, whereas the younger one are towards the base. Now let's quote it with some example, this concept, right? Now do have a look on this diagram. You will find here this picture. This is about the racemose type of inflorescence and this is the cassia. This example is from the cassia flower, which is showing this racemose type of inflorescence, right? Actually this inflorescence is hanging down. If I show you like this in comparison to other, let me try to do that if it is possible. Okay. So we will take later about that. Meanwhile, just have a look on the point. When I am taking this part downside, what is happening? Can I say this is becoming the tip of that? This will become the tip of that. Because I said you this is hanging down, right? And this is a cassia flower inflorescence where the tip is hanging down. And can I say this is a base part now? Because it is hanging down. It is having, can you see buds are there, still the flower has to be formed. Can I say it is a younger one? So younger one is at the tip and older one is at the top because it has, the bud have been opened out and you will find the flower here. So here at the base, the older are there, at the tip, the younger one is present. Such type of arrangement you call it as racemose arrangement, means this inflorescence you call it as racemose and arrangement you call it as acropetal arrangement. Fine. Next, this example is shown to you from the jasmine. Can you see the main floral axis is ending up into a flower and the younger one still buds are at down. Can I say here older one, this is the younger, I mean to say the younger one is towards the base and older one is towards the apex. Fine. So just have a look on the diagram. In your book of NCERT, they have shown you this picture, right? And for this only diagrammatic they have shown you, but I try to give you the actual picture of that, where you will find the older, the bloomed up, right, or open flower is at top. Open means older obviously, which is still not open, they are younger, they are at the base. Such type of arrangement, you call it as basipetal arrangement. And you will find it in which type of inflorescence? Cymose type, right? So this is about the few terminology which I tried to complete. I thought it is important, we should take that into consideration even, because the reproductive include the flower as well as inflorescence, right? I hope so it is clear to you. Now we are going to take our next topic of discussion, that is the fruit, right? So after the fertilization, what is going to happen? The ovary is going to convert into the fruit and ovules are going to convert into the seeds. Now let's talk about the morphology of the fruit in little bit in detail. Like here, if I am taking the general concept about the fruit, first of all you should know this is the characteristic feature. This is a characteristic feature of flowering plants. Which flowering plants? That technically you call them as angiosperms. We are discussing about angiosperms, right? And can I say these fruits are the mature, or you can say these are the ripened ovaries? Mature, or you can say these are the ripened ovaries, right, which is formed after the fertilization. So after the fertilization, what is going to happen? This mature ovary, that is going to convert, or you call it as a fruit, whereas the mature or the ripened ovules, that you call it as seeds. We will take seeds discussion in our next lecture, but right now we are going to take about the topic fruit. Fine. So now in the case of fruit, if we will discuss, we have different types of the fruits. Let's take the first type, you call it as parthenocarpic fruits. What are parthenocarpic fruits? That fruits which are not formed, or you can say they are formed without fertilization. Are you getting that? Fertilization is not required for such fruits and they are seedless. And scientists are preferring such type of fruits in which the seeds are hindrance while we are eating. Like you are eating watermelon, no? Many times the seeds are coming in your mouth. So they are trying to make the watermelon which should be seedless. Such type of fruits where the seed is hindrance while eating, they are trying to make it as a parthenocarpic fruit. So what is parthenocarpic fruit? Which is formed without fertilization and they are seedless. They are seedless fruits. For example, now very important, banana. Now I repeat this concept once again. After that, yes, the parthenogenesis is slightly different. The word what you are asking, parthenogenesis is different thing, where we discuss the organism is forming from the female egg. That is a parthenogenesis, which is a far away of our today's discussion. Yes, example will be there. Honeybee in the case of animals, insects, honeybees. Even in plants, rarely we can have even the parthenogenesis. But don't confuse the word parthenogenesis with parthenocarpy, right? So if you have good knowledge of term, that's good, but you should know where to use which term. Right now we are discussing about the term Parthenocarpy is the process. Parthenocarpic is now like an adjective. Parthenocarpic fruits which are formed without fertilization and they are seedless fruits. An example I have given you for the banana. Now one example I set for you, banana is an example here. Can you say me any example where parthenocarpy should not be done? We are saying that parthenocarpy should be done, right? So they are without, sorry, I must write here the seeds. They are seedless fruits, right? That's fine. So I again ask you this question. I repeat, where the parthenocarpy should not be done? Fruits without seed, without fertilization, seedless fruit, that you call it as parthenocarpic fruit. Now say me this question what I asked, where the parthenocarpy should not be done? No, not that. Think about in which fruits you are eating only seeds. Now where seeds are required, where you are eating the seeds, think about that fruit. Not the custard apple, you are not eating the seeds there. Grapes, you can eat the seed, but this is not the main part of the fruit to eat. Mango, obviously you are not eating the seeds, you are eating their pulp, right? Watermelon, not an answer. Pomegranate, very nice. One student answered that pomegranate, you are eating the seeds. If we do parthenocarpy here, then what is left? Nothing is left. So that's why the parthenocarpy should not be done in such fruits where the only edible part is a seed, where only edible part is a seed. There the parthenocarpy is prohibited, right? So such type of things we are going to, guava is okay, fine, but the main is not only the seeds. It is edible, that's fine. The seeds are edible, it's fine, but this is not the only edible part, right? So where the only edible part are the seeds, there parthenocarpy should not be done, that I am saying, right? Where one example just now you have discussed, that is the pomegranate. So this is actually the NEET. They will say you one thing and apply something else, but you should know the basic concept very clearly. Types of fruit you should know. From your day-to-day life, they will pick the questions, right? So one or two questions can be linked like that, right? So this is one of the introduction regarding the fruit. Now coming to the next part, let me to take the types of fruits now. Types of fruit. One I discussed based on the fertilization, that is a separate topic I have given you. Right now I am taking the types of fruits based on which part of flower is giving the fruit. You know that ovary is responsible for giving the fruit after fertilization. But sometimes what happened without fertilization, you can say the some parts, or you can say without ovary, the edible part can even be developed. If the part of fruit develops other than ovary, that you call it as a false fruit. So you are having two types of fruits, false fruit and the true fruit. Technical term for that is what? U-carp. Wherever you find the word U means true, carp means fruit, true fruit, right? False fruit, you call it as a pseudo-carp. Right? Again, carp means fruit here, pseudo means false. So that fruit which develops from ovary, that you call it as a true fruit. And which is from other than ovary, that you call it as false fruit. And don't think that if the false fruit is there, they will not have true fruit. For example, if I give you the example here like apple, and here I give you the example of the mango, right? True fruit, what you are eating, like mango you are eating, grapes you are eating, these are all true fruits. But right now I am discussing about the apple. In the apple, I am not saying that completely it is a false fruit. What you are eating, the pulp part, that is a false fruit, because other than ovary, this is from its thalamus part. The thalamus is becoming pulpy and it is becoming nutritious, and we are eating that part. And what the central one you throw out, which is carrying the seeds, that is actually the true fruit. Are you getting that? So apple is having both the types of fruits. In the center it is having true fruit. Outside what you eat, that is a false fruit, right? For example, like suppose I am taking a little bit, suppose I am taking, this is a for apple, and in the center you will find this type of thing, right, where the seeds are there like this, right? This you call it as a false fruit, right? In the center it is having the true fruit, right? So this is edible here, this is not edible. Edible means which you can eat, that is edible part is a false fruit here. Other example for the false fruit is even there, like cashew is one of the example. What you are eating, that is a false fruit, but their true fruit and false fruit both are edible, right? We will not go with that complexity. Again I say only terminology, introduction of the things are happening, but so much interesting examples are there in bio, and it is all in your surroundings, right? I want to convey you that thing, right? So first the types of fruit we discussed, true fruit and the false fruit, that you should know. So now coming to the next one, I am taking the parts of the fruit now. What are the parts of fruit? Basically fruit consists of two parts. One is the pericarp, second is the seed, right? Pericarp is the fruit wall. Do remember here the word peri, wherever is there, that means around. So what is around the fruit? That will be obviously its wall. The fruit wall, you call it as pericarp. Fine. Now seed, you know very well, just now we discussed, these are the ripened ovules, and definitely in our next lecture we are going to complete the seed part of that. Now we are going to focus on the pericarp. Based on pericarp, based on this, now we are having types of fruits. What is that? What are that fruits? One is the dry fruit, right? And next is the fleshy fruits, right? Which are the dry fruits? Where the pericarp is not differentiated into apicarp, mesocarp and endocarp. What are these? These are the layers of the pericarp. But here in the fleshy fruit, the pericarp is differentiated. Differentiated into what thing? It is differentiated into outermost layer, you call it as apicarp. Central layer you call it as mesocarp. And here you are having the endocarp. See, I already said you the word carp. That is the term related to the fruits. If the pericarp is differentiated into all that layers, epicarp means, epi means out, meso means middle, endo means inside. So these three layers from outside to inside. I repeat this thing. This is again important question. Anything you are learning in sequence, you should know, are you learning from outside to inside or inside to outside? Right now I have written from outside to inside. Epicarp is the outermost layer, mesocarp is in a middle, and endocarp is in a innermost layer of the pericarp around the fruit. If such type of differentiation is there, can I say the pericarp in this situation will become thick and fleshy? But here the pericarp is not thick and fleshy, it will be dry. For example, let me to take you the example of pea. Because when I am saying dry fruit, what come to your mind? Like almonds are coming, pistachio coming. So no doubt they are even the dry type. But in common life, you are looking to a pea pod. Even that is a dry fruit. where when you peel it off, that white color outside skin, that you call it as pericarp. It is not differentiated into epicarp, mesocarp and endocarp. But on the opposite side, if I give you one example like mango, when you see mango from outside, like it is orange, green, different varieties have different colors, or different stages of mango have different colors of the skin. That is the epicarp. And what you eat, that is a mesocarp. And what you throw and it is having the hairy fibers on that, that is endocarp. Don't call it as seed. When you break it, inside then you find the soft seed is hidden there, right? So if such arrangement is there, that type of fruits which become fleshy, I must say its pericarp become fleshy. Here in mango, which part become fleshy? The mesocarp become fleshy. And it is not the truth for all fleshy fruits. In some time you can eat epicarp, mesocarp, everything you can eat. Like in case of tomato, you can eat every part. In the grapes, you can eat every part. Epicarp, mesocarp, even seeds you can eat inside that, right? So in different fruits, in the pericarp, different things are edible, or some are not edible. Right now in mango, I have given you the example, the edible part. Edible, I repeat, that means what you can eat. Edible part in mango is a mesocarp, right? No doubt you are making pickles, even you are cutting, you are eating the epicarp as well. That is a separate issue. But generally, as a food, like we are dealing with that, we are eating mainly it's a mesocarp part, right? So just go with that concept. So this is the one category of fruits we have discussed based on the types of pericarp, what they are having. Again, repeat. The parts of fruit, it consists of pericarp and the seed. Pericarp, you call it as a fruit wall. Based on pericarp, you are having types of fruits, dry fruit and the fleshy fruit. In dry fruit, pericarp is as such like a single layer. You cannot differentiate, it is not differentiated actually, and the pericarp is not fleshy here. Whereas in the fleshy fruits, the name is indicating the pericarp will become thick and fleshy. The pericarp will become thick and fleshy. And the edible part can be epicarp, can be mesocarp, can be endocarp, or can be all three even, depending upon fruit to fruit. But you can easily differentiate among the three layers there, right? So this is about the types of fruit. Now one category under the fleshy fruit. Let me to take that. Under the fleshy fruit, you will find one of the category as an example. It is having further many different types of category. You will find simple fruit, aggregate fruit, composite fruit. We are not going in that much of detail. Only you should know the connectivity of 10th and plus 1. Much more we have to learn. We have very good petty time. We are having that time we are utilizing with all the things in more detail, which can help you to become better near to your NEET exam. And obviously on your NEET exam you will be produced out like a best student among all, right? Try from your side. We are even trying, and I hope so you are getting, but the thing you have to revise the thing. On the first day we have discussed the base, you should not forget. What we have started from the beginning, revise that, then learn the new things, right? This is more important. So here the fleshy fruit, one of the example of it types. What is that? I am taking as a drupe, right? Or it can be berries, it can be the tapo, it can be ballistula, so many other different types further are there under the fleshy fruit. Just now I am taking only one type, that is a drupe. Otherwise fruits can be categorized further into simple, aggregate and the composite or multiple type, under which further this will come. But right now simply under the fleshy fruit only one type I am taking, that is a drupe. Now what is that drupe? Can I say the drupe is under which category? It is a simple fruit, and under the simple fruit it is a fleshy fruit. It is a fleshy fruit, right? Simple fruit, I mean to say that it develops from one single carpel, or you can say right now the mango I am discussing, so I must write only for mango. It is derived from the single carpel, obviously of a flower, single flower. Some fruits are developing from many carpel of one flower. Like, can you see the custard apple? The custard apple, can you see from outside? So many ovaries you will find. It is not a simple fruit. It is an aggregate, collection of small fruits over there, being it is formed from one flower but many carpels, right? So right now it is not aggregate. This is a simple fruit, means it is developing from one carpel only or one ovary and a flower, a single flower. So this is a simple fruit. Fleshy fruit, you know why it is fleshy fruit now. The drupe, even you must remember, its feature most important, its endocarp is hard and stony. This is very, very important NEET question, right? This is very, very important. So what is special in the drupe? It is having the endocarp hard and stony. This is very important. And it is developing from the single carpel which is having superior ovary. Now you know superior ovary means I am talking about hypogynous flower. That's why in the beginning of the session I realized I must say you the types of flowers. Hypogynous flower where the ovary is superior. Such type can, some categories of that can form the fruit as what thing? As a drupe. What example comes over there? Mango and coconut, right? As per your NCERT book I am writing that. Even more can be the example, but according to NCERT I can say and, right? So right now mango and coconut, but do remember they are totally different plants, but the category of the fruit is same, that is a drupe. Are you getting that? In case of mango, do remember this is a dicot. The coconut is what? Monocot. But the type of fruit they are having categories common to both. Drupe will be the category. Reason why? Because both are showing this type of feature developing from the single carpel superior ovary. Right now let's check about a slight difference among that. Although we have discussed the common thing, now the slight difference. Apicarp, here they have shown the orange color, or you can say the type, the green color layer outside, that you call it as apicarp here. Here is the green color which is removed actually, then you get inside. Apicarp have been removed. But here the mesocarp is edible. What is edible here? Mesocarp. But here mesocarp is fibrous. You are using in a form of formation of husk, right? So it is not edible here. Endocarp I said in both the cases is hard and stony. Then what is edible in the coconut? The white part what you eat and what you drink, both you call it as what? That you call it as endosperm. What is the edible part of the coconut? Endosperm. One is in a solid form, you eat that. One is in a liquid form, you are drinking that. So it is the double endosperm part in the case of coconut that is going to be edible here. And what is edible in case of mango? The mesocarp is edible, right? And why you call both as a drupe? Because they are developing from single carpel which is having superior ovary. Are you getting that? Both are drupe, and endocarp is going to be hard and stony over there, right? Endocarp. Don't confuse endocarp with endosperm now. Endosperm is the edible part of coconut, whereas the endocarp is the layer of the fruit in both the cases, right? Both this point is common. This is hard and stony, right? So this is all about our discussion on the fruit. You must know at least this much of point as an introduction, right? So like that we have completed the topic of fruit, but I said you in the fruit we are having seeds as well, that we'll take in our next lecture. This is all for today. Thanks a lot, student.
Okay, so hope you all are good, enjoyed festival also. So now coming, we have already discussed that what are the economically important insects. Already said that honeybee, Apis indica. Then I said Bombyx murray, sericulture, lake industry, lake culture. Then
These are few mosquitoes, those who are causing the diseases like Anopheles, like Culex, and like Aedes. I already said about this all. This is one gregarious pest that it is coming in thousands and eating the entire crop within one night, one day. It is very dangerous. Already I said that you have to remember. Now coming on this living fossil, then again Lepisma silverfish. All we have completed. Yes, just see, it is one arthropodan animal. And this arthropodan animal, it is looking that it is known as the crayfish. It is not a true fish. Crayfish is not true fish. Crayfish is not true fish. It is an example of arthropoda. This you have to remember. Crayfish, Apricots. They are known as the false fish because they are looking like fish but they are not fish. It is the arthropoda, crayfish, Apricots. That is the arthropoda. Now after it we are coming on the next one. From here I will say you something different. In animal kingdom, students are getting problem how to learn the examples. This is a big problem related with the animal kingdom. So from this phylum I will say what is the method we are adopting at C. Chaitanya Gosala campus. Okay, when you will come to our campus, how I will say how to remember the example. So today I will focus on that, how to remember the example, because every phylum is having so many examples. How you will remember the examples? So today's topic is based on mostly them. So now coming on the phylum that is known as the Mollusca. I said arthropoda means arthros. Arthros means jointed. Poda means appendages. The animals, those who are having the jointed appendages, they are known as the arthropoda. Now coming on this one, Mollusca. The meaning, first I will say, reply the answer of one question. Which is the largest phylum? Which is the largest phylum? Fastest finger first, please give your response. Which is the largest phylum? Which is the largest phylum of animal kingdom? Anyone will say, which is the largest phylum? Yes, 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 Tanmay, very good. Arthropoda, Dikshita arthropoda, then female Sheikh arthropoda. Yes, you all are giving the correct answer. So, which is the largest phylum? That is the arthropoda. What is the second largest phylum? That you have to remember. What is the second largest phylum? That is the Mollusca. So first largest phylum is the arthropoda and the second largest phylum is the Mollusca. Okay, so first largest phylum arthropoda, second largest phylum Mollusca. I said out of 10 animals on this earth, out of them 7 are insecta. So 7 upon 10, that is insecta, and that is the second largest phylum, that is the Mollusca. What is the meaning of Mollusca? They are having a soft bodied. Soft bodied animals are known as the Mollusca. That is why for protection, surrounding them there is formation of a shell. Okay, surrounding them the shell is present. Have you seen the pila, apple snail? Have you seen the pila, apple snail? It is having one calcareous shell. Calcareous shell means which is made up of calcium carbonate. Shell is made up of calcium carbonate plus conchiolene protein. Conchiolene protein. So this is one point you have to remember. The meaning of Mollusca, it is the second largest phylum. It is the second largest phylum. The meaning of Mollusca, it is the soft bodied animals. And what I said, they are covered by a shell. And this shell is made up of calcium carbonate plus protein. It means for protection, they are having one calcareous shell. Now we are coming on. What are the examples of Mollusca? Please note it down, the example of Mollusca, because today I will say how to learn the example. So you are able to get the trick only when you will write the name of the example. And I will request, please note down the example in a sequence. Getting? Please note down the example in a sequence. So what is the first example? That is known as the pila. Phyla is known as the apple snail. Why it is known as the apple snail? Because it is looking like apple. Why it is known as the apple snail? Because it is looking like apple. So that is the apple snail. Phyla is known as the apple snail. Please put number 1, phyla, apple snail, because today I will say how to remember the example. So phyla, that is known as the apple snail. Just see, that is phyla, it is apple snail, and this is the shell which is made up of calcium carbonate. So this is the phyla, apple snail. What is the second example? Pink tada. Pink tada. Pink tada, it is known as the pearl oyster. Pearl. I think you know about the pearl. It's a precious stone. And pink tada, it is producing this precious stone. That is why it is known as the pearl oyster. Yes, it is pearl oyster. So that you have to remember that pink tada, it is known as the pearl oyster. So first what I said? First I said phyla, that is known as the apple snail. Second I said pink tada. Pink tada, that is known as the pearl oyster. Pink tada, that is known as the pearl oyster, because you have to learn the example. Pink tada, that is known as the pearl oyster. See how beautiful it is producing the pearl. You will get surprised. Why this mollusca is producing the pearl? Happily or sadness? It is producing the pearl for its protection. It is producing the pearl for its protection. Okay, it is not producing happily. It is producing the pearl surrounding the foreign body. It is secreting the protein. So it is the pink tada, that is known as the pearl oyster. How beautiful it is. It is producing pearl. That is the pearl oyster. Pink tada. It is known as the pearl oyster. See, third example you have to remember. Sepia. Sepia, that is known as the cuttlefish. Sepia, that is known as the cuttlefish. Sepia, that is known as the cuttlefish. So what is the third one? That is the sepia, that is known as the cuttlefish. So sepia is known as the cuttlefish. This is the third one you have to remember. Sepia, it is known as the cuttlefish. Okay, these all are the tentacles present on the body surface. So sepia, it is known as the cuttlefish. This is sepia, it is known as the cuttlefish. Okay, so this is the example number 3. Loligo. Fourth example, it is known as the squid. Squid, it is known as the squid. Elongated body, it is known as the squid. Loligo, it is known as the squid. Fourth example, loligo, that is known as the squid. Loligo. Now, fifth one, that is the octopus. Octopus. How many arms octopus is having? Anyone will say? How many arms it is having? Octa means 8. It is having the 8. That is why it is known as the octopus. And very surprising, it is having the eyes also, which are similar as our eyes. Okay, very good. You all are replying that it is having the 8 arms. So octopus, that is known as the devilfish. Aplysia, it is known as the sea hare. Aplysia, that is known as the sea hare. Aplysia, that is known as the sea hare. Hare means, anyone will say, hare means rabbit. Hare means rabbit. It is looking like somewhat rabbit here. So that is the sea hare. Aplysia, it is known as the sea hare. Sixth example, aplysia, that is known as the sea hare. Dentalium, it is known as the tusk cell. Ever you have listened? Elephant tusk. Elephant is having tusk, na? Elongated, pipe-like structure. The body of this mollusca is present. The body of this mollusca is present in a tusk-like structure. That is why this is known as the elephant tusk cell. Clear? So this is the 7th number, elephant tusk cell. Chaetopleura, it is known as the chiton. Chaetopleura, it is known as the chiton. Chaetopleura, it is known as the chiton. So sometimes what is the problem occurring? when we are discussing about the animal kingdom, now today I will discuss some difficult thing, and I will say how to simplify the difficult thing into the simpler thing. Okay, this is the our motto. So there are so many examples in every phylum, and students are saying, sir, how to remember it? But when you will come to see Chaitanya, our Gosala campus, have you filled the form? Have you filled the admission form till date or not filled? If filled, then please give thumbs up. Please say yes, you filled the form. Please give thumbs up if you fill the form. Say me, how many of you filled the form? How many of you filled the form? Please give the thumbs up if you have filled the form. Very good. Asif, very good, very good. You all filled the form. Yes, I got the message also that most of you filled the form. Those who are remaining, requesting them, please fill the form as soon as possible. Okay, because soon it is April now. Soon we are going to start the batches now. So just do it very fast. Okay, so coming, because you know, early start, half done, well begin. So do it fast. So now coming here, that how to remember the example. Anyone will say, how many example related with mollusca I said? Say me number. 1, 2, 3, 4, 5, 6, 7. How many examples I said about the mollusca? How many examples I said? Yes. Kotha. That is the Nabya Sri Kotha. You have given the correct answer 8. You are sincere in the class. 8 example I have written about the mollusca. Phyla is known as the apple snail. Pinctada is known as the pearl oyster. Sepia is known as the cuttlefish. Loligo is known as the squid. Then octopus is known as the devilfish. Aplysia is known as the sea hare. Dentalium is known as the tusk shell. And Chaetopleura is known as the chiton. That is why I said, yes. That is why I said write the example in a sequence. Now here, it's my duty to simplify and help you to remember the example. So in every phylum, at the end of every phylum, I used to say one short form. At the end of every phylum, I used to say a short form. With the help of this short form, you are able to remember all the examples of that phylum in lesser time. So what is the short form related with the mollusca? I said how many examples? 8. 1, 2, 3, 4, 5, 6. That is 6, 7, 8, and here one more will come. Okay, that is here. That is the name of the phylum mollusca. So here that is the 7. This it will come. That is the 5. Then it will come 6. Then it will come 7, and it will come 8. So what is the short form? अरे पापा सितंबर अक्टूबर में दोहा चले. It is combination of your Telugu, Hindi and English. You know the meaning of papa? Okay, in Telugu, very famous term papa. Doha, you know, it is the name of one country. And then I added the 2 months, September, October. So what is the short form related with the example of mollusca? अरे पापा सितंबर अक्टूबर में दोहा चलें. How much time it takes to remember? Anyone will say how much time it takes to remember? I think less than 5 seconds, 10 seconds. Okay, say me what I have written. अरे पापा सितंबर अक्टूबर में कहां चलें? Where you want to go? Okay, that I said doha. So see, A for Aplysia. A for Aplysia, it is known as the sea hare. A for Aplysia, it is the sea hare. P for Phyla. Phyla, that is known as the apple snail. P for Pinctada. Pinctada, that is known as the pearl oyster. S for Sepia, that is known as the cuttlefish. Sepia, that is known as the cuttlefish. O for octopus, that is known as the devilfish. Okay, These all are the example of mollusca. I have added the name of the phylum also. So when you will remembering so many phylum, there is no confusion. That is the mollusca. Okay. D for dentalium. D for dentalium. I have written D for dentalium. CHA, that is the Chaetopleura, and L for, that is the Loligo. I have written Pawan Agrawal special, that every phylum you will get one short form, because there are so many examples. Okay, Salma is asking, how would you get these ideas? Okay, I am getting the ideas because I have to simplify the subject. Okay, because it is not my duty to teach in the class and come out from the class. If you are not able to remember the example, then how you will score good in the exam? So you can change. Okay, Krishna is writing, very good. Krishna is writing, Arey Papa, September, October mein Delhi chale. Yes, you can change the name of the city as per your choice. Arey Papa, said our mother, do chicken leg piece. Okay, very good. Toxic boy. Okay, change your good name because you are writing good. So you can change. I have given you the idea. Any good idea come in your mind, please share. Like he said na, chalo Papa Delhi chale. Okay, he said ma into dosa le roju. Okay, that what is Arey Papa, September, October mein Delhi chale. Yes. Okay, so this is the one. 9 examples. No, beta, 8 examples. 8 examples. 9th one is the name of the phylum, mollusca. Okay. So that is the one thing that you have to remember. I will say it again. Arey Papa, September, October mein doha chale. Say along with me. A for Aplysia, P for Pila, P for Pinctada, S for Sepia, O for octopus. These are the example of mollusca. Again saying D for dentalium, C for Chaetopleura, L for Loligo. 8 examples of mollusca you are easily able to remember. No, SDC, you are more intelligent, sir. No, you people are more intelligent than me. I will prove it. If you will give me a paper of NEET, I am able to solve only the question of zoology, SDJ, but you are able to solve the questions of physics, chemistry, botany and zoology. So you are 4 times more intelligent than me. I proved. How can you say I am more intelligent? You are more intelligent, SDC. Are you getting my point? So you are more intelligent. So just see, that is the one thing I said. Arey Papa, September, October mein doha chale. I think you are getting all the example. A for Aplysia, P for Pila, P for Pinctada, S for Sepia, O for octopus, M for mollusca, D for dentalium, CHA for Chaetopleura, LE for Loligo squid. Okay, so this is the one thing that you have to remember, that example of phylum mollusca. Okay, say me, this short form is liked by you or not? If liked, please give thumbs up. It is liked by you or not? Yes. Alu, Ravanna is saying, sir, remaining phylum shortcut. Leave something, then you will come to our compass. At least I am having something to give you, If I will say all the things on the online, why you will come to me? Come to me, I will share all my knowledge with you, because it's my duty to give you 100% knowledge. Okay, so I said just how to remember the things. Okay, so I said just how to remember the thing, that is I said. So from here, okay, I will follow his words. From here, in every phylum, how many remaining? I will give you the short form. Okay, done. Good suggestion. So now just Arey Papa, September, October mein doha chale. Now coming on this one, Echinodermata. The meaning of Echinodermata is spiny bodied animals. They are having spines on their body surface. That is why they are known as the spiny bodied animals. Clear? So now Echinodermata, they are exclusively marine. How many examples of Echinodermata I will share you again. Today I said na, today I will say how to simplify the zoology. So I simplified all the examples of mollusca. Are papa, September, October में दोहा चले. I think you are remembering all the examples of that mollusca. Now coming here, first example of Echinodermata, asterias. That is known as the starfish or sea star. How beautiful it is looking. We are able to divide. These are the 5 arms. Okay, are you getting? Okay, this is the starfish. Starfish or sea star. Just see, starfish or it is the sea star. First example, starfish. Again, I have taken one picture. Asterias, that is the starfish. This is the first example. Starfish. Are you getting? Second example, that is the echinus, sea urchin. Now this time you have to prepare short form. I am giving you a job. Okay. Now this time you have to prepare the short form. Are you getting? I will say all the example one by one. First example I said asterias. That is known as the starfish or sea star. Clear? Second example is the echinus. That is known as the sea urchin. Echinus is known as the sea urchin. That is the second example. Echinus. That is known as the sea urchin. Third example is the antedon. Antedon. That is known as the feather star. Antedon. That is known as the feather star. Feather star, you know, feather. Feather, these are the feather, wings, feather-like structures are there. Antedon. Antedon, it is known as the feather star. It is looking like this. Antedon, it is known as the feather star. Cucumeria. Cucumeria, it is known as the sea cucumber. And I will share one wonderful story related with the sea cucumeria. Cucumeria is the animal, when it is getting angry, it is throwing all its intestine outside. And God has given a power to Cucumeria to regenerate its intestine. That property is known as the autotomy. Evisceration. Evisceration means removal of the internal viscera. And again, there is a process that is known as the regeneration. By the process of regeneration, it is synthesizing its alimentary canal again. Getting na? So wonderful example of regeneration. Cucumeria. It is able to show its alimentary canal and again regenerating. It is the Cucumeria. First example I said, that is the asterias, starfish. Second example I said echinus, that is the sea urchin. Third example I said antedon, that is the feather star. Please be ready with pen and pencil. You have to prepare the short form now. Okay. Fourth example, that is the Cucumeria, sea cucumber. Cucumeria, sea cucumber. Okay, it is looking like this. Cucumeria, sea cucumber. Ophiura, brittle star. See, someone has taken the Ophiura in the hands. Brittle star, that is the Ophiura. Brittle star, that is the Ophiura. Getting? Brittle star, that is the Ophiura. It is looking like this. That is the Ophiura. Okay. So now it's your turn. I said 5 example of Echinodermata. I said 5 example of Echinodermata. I will show you again. See, 5 examples of Echinodermata: asterias, starfish; Echinus, sea urchin; third one, antedon, that is known as the feather star; fourth one, that is the Cucumeria, that is known as the sea cucumber; Ophiura, that is known as the brittle star; and eagle ate chocolate and orange. Very good. An eagle ate chocolate and orange. Very good. This is one good. You are preparing one. Auntie Iroju office cut. Very good. You all are trying. I am happy. Okay. Please share your short form. Just say the short form and please write the full form also. ओके, एग ऑमलेट अच्छा है, कुकुम्बर मत डालो. ओके, बहुत बढ़िया, वेरी गुड वेरी गुड. आर एग ऑमलेट अच्छा है. ओके, वेरी गुड, यू ऑल आर ट्राइंग. एंट, एलिफेंट एंड कैट ऑर्डर. वेरी गुड. ओके, वेरी गुड. ओके रिकी, इट इज डिफरेंट. ओके, वेरी गुड, you all are trying. Okay. Just so you all are trying your level best. Who has taken this? Aishwarya, come on, Europe again. Very good. You have taken my short form. Very good. Aishwarya, come on, Europe again. Who has written this? Very clever. Neela Vani Kondala. Okay. One slide came in between. Very good. So Aishwarya, come on. Remaining people are also writing correct. Krishna and ant, elephant and cat order. So just see now, what is the duty of a faculty, teacher? To develop the spark. You people are full of energy. So you are able to create. I said now, always create the short form as per your convenient. Why? Because short form will help in the examination room. Whenever we are going to write the exam, examples are getting mixed and sweat is coming. So if you will remember with the help of short form, okay, then an elephant attacked on campus. Balu, very dangerous. An elephant attacked on campus. Very good. So now just see, I have written Aishwarya, come on, Europe again. A for asterias, starfish. A for asterias, that is the starfish or sea star. C for cucumeria, that is known as the sea cucumber. Okay, C for, okay, someone has Venkata Siva Kumari, you have written in the Telugu. I don't know exact Telugu, but you are trying your level best. Ajoy energy, opera cut. Okay, so just see that Aishwarya, A for asterias, C for cucumeria, sea cucumber. O for ophiuria, that is known as the brittle star. Okay, O for ophiuria, that is known as the brittle star. E for echinus, that is known as the sea urchin, that is the echinus. Echinus is known as the sea urchin. And A for antedon, that is known as the feather star. So you have to remember that what I said, Aishwarya, come on Europe again. So today I said two short form. What is the first short form to remember the example of mollusca? अरे पापा, सितंबर अक्टूबर में दोहा चले. What I am saying, Aishwarya, come on Europe again. A for asterias, starfish. A for asterias, that is the starfish. C for cucumeria, that is the sea cucumber. Okay, sea cucumber, that is the one. Okay, so that Neelavani, yes, very good. You are writing something. Aishwarya, asterias, that is the starfish. C for cucumeria, that is the sea cucumber. O for ophiuria, that is known as the brittle star. E for echinus, that is known as the sea urchin. And A for antedon, that is known as the feather star. Ultimately, you have to remember the example. So better to remember the example with the help of one short form. These short forms will help you a lot. Okay. All Echinodermata are cool. Oh, very good. Sai Sohan Reddy. Okay. So Neela Bani is saying, I said funny, but sir also taken some example. Yes. You taken, but I don't know Telugu, so I have not replied. All enemies are eating cucumbers and onions. Very good. And cat order, or say that elephant angry. Okay, so okay, it's good. So what I said, you are trying. It's a matter of happiness that you are involving in class. So are you getting? You have to prepare short form of every phylum. Otherwise, not possible to remember the example. Now we are the human beings, na. So ultimately, what is our target to remember? So when you will come within 10 minutes, you are able to remember the entire animal kingdom. Examples of entire animal kingdom. Okay, so this you have to remember, that what I said, that Aspharia, come on Europe again. Aspharia, A for Aspharia, A for Asterias, C for come, C for Cucumeria, O for Ophiuria, E for Echinus, A for Antedon, that is also known as the featherstone. So these are the few examples of Echinodermata. Now I am coming on the last part of non chordata, that is known as the Hemichordata. Okay, I am coming on the last part of non chordata. Yes, someone has written, Salma, you have written correct. Aeroplane crashed over Egypt again. Very good. A for Asterias, aeroplane. C for Cucumeria. O for Ophiuria. E for Echinus. A for Antedon. Wonderful, Salma. Very good. R eat cucumber and oyster. Very good. So amma cook onion egg again. Manisha, wonderful. Wonderful, Manisha. You have written amma cook onion egg again. So you all are having the creative mind. Na? Are you getting how to remember the example? Say me if this method is liked by you. Give you a thumbs up. It is liked by you. Are you learning something? How to easy the zoology? Okay. If it is liked by you, please give your thumbs up. Then I will say the remaining one. Very good. Very good. Very good. Very good. Okay. So I am happy that you are getting the subject. September, October में दोहा चलें. See me. This short form is related with which phylum? अरे पापा, September, October में दोहा चलें. This short form is related with which phylum? Which phylum? Mollusca. Very good. Okay. Aspharia, come on Europe again. Aspharia, come on Europe again. This short phylum is related with Aspharia, come on Europe again. This short form is related with Echinodermata. Very good, very good, very good. So please prepare one short form, and when you will come to campus, na, show me. Sir, I prepared this. Whenever free, na, please prepare a short form for arthropoda and share me in tomorrow class. What you have prepared? Write the full short form plus detail. Now we are coming on the last phylum of non chordata, that is known as the Hemichordata. 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 Hemi means of. Chordates means chordata. Those who are having the structure, that is known as the notochord. Notochord is a structure which is present in the chordates. Present in chordates. Okay, it is present in chordates. They are considered as the half chordates. They are not having notochord. They are having one structure that is known as the stomochord. So previously, Hemichordata included in chordata. Previously, Hemichordata included in chordata because they resembling stomochord with the notochord. So previously it was a subphylum of chordata, but now they recognize that stomochord is different, notochord is different. now they recognize stomochord is different and notochord is different. So now they are saying it Hemichordata. So now the Hemichordata is placed as a separate phylum under the Non Chordata. Are you getting? Semichordata, it is included under Non Chordata. I said na, earlier considered as a subphylum of Chordata, but now it is placed as a separate phylum under Non Chordata. Okay, so why previously it was included and why it is removed? Because they were thinking that stomochord is the notochord, but now they recognize that notochord is different and stomochord is different. So now they place this animal as a separate, this phylum as a separate phylum under the Non Chordata. So in Non Chordata, how many phylums we discussed? Please note down the number, please say me the number, please write fastest finger first. How many phylums we have discussed in the Non Chordata? How many phylums we have discussed in the Non Chordata? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Anyone will say, yes, Krishna, I got your short form. Yes, Jyoti is saying 8. Anyone interested to change the number? Yes. How many phylums? Yes. Thapan, you said 9. Count with me. Porifera. Clear? Coelenterata, Ctenophora, Platyhelminths, Eschhelminth, Annelida, Arthropoda, Mollusca, Echinodermata, Hemichordata. So all those who have written 10, they all are correct. Total 11 phylum we have to read. These 11 phylum that we have to read, they are divided into two. One that is the Non Chordata and second one that is the Chordata. So started from Porifera up to the Hemichordata. How many phylums? 10. I will repeat again. Porifera, Coelenterata, Ctenophora, Platyhelminth, Eschhelminth, Annelida, Arthropoda, Mollusca, Echinodermata, Hemichordata. These 10 phylums are included in the Non Chordata and it is a separate phylum. It is a separate phylum. So total 11 phylum we have to discuss in first year. Okay. Yes. Someone is asking vertebrate and invertebrate. So see, this is different classification. When I will say about the Chordata, phylum Chordata classified into 3. Urochordata, Cephalochordata, Vertebrata. So if you want to classify as per the Vertebrata and Invertebrata, beta, Nabhyasri, you are asking vertebrate and invertebrate. So when you are saying about the invertebrate, so you have to remember non-chordates plus Urochordata plus Cephalochordata. They are also invertebrate because Vertebrata is one subphylum. Are you getting, Nabhyasri? So this is the one point that you have to remember. So Hemichordata, it is including 2. See, very first, Balanoglossus, tongue worm, and this is tongue worm, Balanoglossus, and that is the Saccoglossus. So today we have completed up to the non-chordata as per the schedule given. Tomorrow I will say about the chordates. Enjoy the class, and tomorrow I have given one homework you. Please write the short form of Arthropoda. Share me with detail what you are writing. Okay. Thank you very much. Thank you. We will meet again tomorrow. Thank you. Thank you. Thank you.